Hello, everyone. In this chapter, we will talk about how to set up a HUAWEI cloud platform. In the previous chapter, we have completed the development on the IoT end, which can generate vending machine data in the target format and fields and report the data to the IoT platform. In this chapter, we will talk about how to build a HUAWEI cloud platform to complete an end-to-end process covering data collection, processing, storage, and application. After learning this chapter, you will know how to use the common HUAWEI cloud data transmission and storage services, how to execute Linux command lines, and how to build and use an Elastic Cloud Server (ECS) cluster environment. First of all, let's learn about the platform setup process. First, let's look at the two ends. We have developed the development board on the IoT end. In addition, the data is collected and transmitted to the cloud on the IoT platform. On the I end, we have selected HUAWEI Cloud Model Arts as the I development platform. How are they connected? As described in the solution design in Chapter 1. The IoT platform provides a rule engine to forward data to other cloud services. The forwarded data is the JSON message queue data. The developed data format is 3-layer nesting. Therefore, pay attention to fields during subsequent data processing. Data Ingestion Service DISE supports multiple IoT protocols, such as MQTT and COAP, for receiving IoT data. Specifically, a data stream is created and then collects, transmits, and distributes data. The data can be temporarily stored in DISE or dumped to other services. Data can be dumped to Object Storage Service (OBS). Currently, the price of a 40 GB standard storage package for an OBS bucket is 1 CNY per month. Model Arts can directly synchronize and call data in your OBS buckets as well as in other OBS buckets of another account as long as you know the AKSK of the account. In this way, the connection from the IoT end to the I development end is built. As mentioned above, there is only one development board in the exercise, and the reported data cannot support machine learning. Therefore, we use the jar package to generate simulation data. The jar package and the source code will be provided for you. The jar package is deployed on an ECS cluster. In this exercise, we will also describe how to create an ECS cluster and configure a Java environment. The DISE stream can aggregate data generated by jar packages and data reported by the development board. Specifically, configure DISE agent in the cluster. After the process is started, the folder that stores the data generated by jar packages can be monitored. In this way, data is collected to the stream in real time when it is generated. After data is developed in the I development platform, we will obtain some mining analysis results based on the data. It is expected that the results will be remotely sent to devices for intelligent O&M. As mentioned above, the IoT platform can call APIs to remotely control devices. Therefore, after intelligent sales forecast, we will use this function to feedback analysis results. Based on the preceding process, we will purchase and create the following services in sequence. IoT platform. This has been used in the previous experiment. DISE, OBS, Model Arts, and ECS. WinSCP is used to import jar packages. PuTTY is used to run commands. You can also use MOBA if you like.